Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on condensate modeling using PVTP software. So in previous video, we have completed the setup for the add PVT sample. Now we are going to define the pseudo component. All right, in the PVT sample object, a single pseudo component was defined here. Pseudo component 1. This component is designed to represent all the components from C7 onwards. So it's C7 plus. And as such, it needs to be tuned in to accurately, characterize or represent all the C7 plus component. Okay, to do that, I'm going to cancel it. Double click on add pseudo properties. Okay, first we highlight this we highlight this PVT sample initial and then double click on this one. Now it's connected to the PVT sample initial. We have a new object called pseudo properties. Okay, double click on this one. All right, so this is the pseudo properties window. Now we focus on the pseudo properties. And here we have collapse heavy components to one pseudo component, and then boiling temperature using petroleum experts. Critical pressure, critical temperature, critical volume, we are going to use this. TWU admitter. And then we are going to compute or to predict the boiling temperature. And critical properties mode automatic. Okay. We have the mole percent, we know 6.31%. And then we also know the molecular weight, 205. So since neither the specific gravity nor the boiling point temperature are specified in the lab report, these will both need to be estimated. As a starting point for this process, we will input the specific gravity of 0.8. So we will assume specific gravity of 0.8 for this particular fluid. Okay, I'm going to input 0.82 here. And then molecular weight we know based on the report, mole percent we know based on the report. Okay, and then we enable the auto match of densities via boiling point temperature. The options for auto match of densities via boiling point temperatures need to be selected as default. Okay, this is specifically developed by petroleum experts. This means that when the object is calculated, the auto match process will be performed unless, the user decides otherwise. Okay, and the standing cuts correlation we are going to use for the density method. Okay, this method for calculating liquid phase densities is known to provide accurate results near standard condition. As part of the auto match, PVTP performed two calculations of the liquid phase density in parallel. On the one hand, we have the equation of state, all right? The equation of state is used to calculate the K values for a flash to standard conditions, from which the individual phase composition and in turn, the density can be calculated. That's on one hand, the equation of state. On the other hand, the fluid is flashed to standard conditions using K values from the Hoffman plot, which are in turn used to determine the phase composition. With the composition of the liquid phase known, then the standing cuts method can be used to calculate the liquid phase density. All right, so we have two calculations in parallel until we get, a better match. And please note that the use of K values from the Hoffman plot, unlike the equation of state, it ensures that mass balance is met. However, their use is somewhat limited to only at ambient conditions, where the tie lines are straight. Okay, and when automatch is used, PVTP regresses the pseudo's critical properties to match the liquid density predicted by the equation of state to that predicted by standing cuts, by adjusting the pseudo's boiling point temperature in our case. Okay, changing the boiling point temperature will change the value of the characteristic function, or it is called B function, such that a different K value is determined from the Hoffman plot, which changes the phase composition and therefore the calculated liquid density from standing cuts. However, changing the boiling point temperature also changes the calculated critical properties via the chosen correlations, such that the different K values and therefore phase composition and liquid densities are calculated. This process is repeated until either the two methods converge or the maximum number of iterations is exceeded. Okay, in this case, maximum iteration is 200. So it's quite a lengthy explanation. If you're interested to know more about this feature, you can read the PVTP manual. All right. And with the pseudo properties defined, the equation of state can technically be used to perform flash calculations. However, since the correlations predict generic values, the calculated fluid behavior may be quite different to what is observed in the lab, and thus the equation of state cannot be used for predictive modeling. This is therefore a good point to perform a quality check on the fluid model, on the equation of state model. Okay, so first we input specific gravity of 0.82, and we can calculate at this point. Failed to match composition, the unmatched value have been used instead. Okay, so it's too high. Let me check. This one specific gravity 0, comma. So it needs comma 82. Recalculate. Okay, so we get the boiling point temperature of 365.9 degree Fahrenheit. Okay, I'm going to squeeze it first. Okay. All right. And without needing to close any open windows, we can navigate to calculation here. And then let's find the separator. Select separator and put it on the calculation. And then let's double click. Okay, once the separator object is placed on the window, we double click to open the screen. And note that the object screens will open directly on top of the object icon, though can be moved around based on your preference like this. Okay, in the window that opens, we enter the temperature and pressure of each separator. And this can be done manually by either referring to the lab report, or you can also connect it, with the PVT sample. Okay, so we input, maybe I can close it first, and PVT sample, separator here. So I can copy and paste it here. And then, oh, by the way, before the separator train can be calculated, maybe I can put it like this. And the second stage. Okay. The input. Separator train, the input value for variable pressure on 0 PSIA. Oh, sorry. Should be PSIG. So we need to correct also the first stage. So it's like this. Okay. All right, before the separator train can be calculated, the fluid to be used must be selected first. Okay, so like for example, I'm going to select this so that it can be used for separator train computation. So you can do that using here, right click and then select. So you see a green check mark here. Now the separator can be used to calculate the pseudo properties or the fluid within the pseudo properties object. Okay, so I double click and then we can press calculate button. All right, very good. And then go to results table, stage result. Now let's compare it with the data here, the separator. Okay. So first we have stage GOR, the first stage, 5,995 SAF per STB. And then for the second stage, important thing is the oil density of 788. All right, once again, the calculated liquid densities at standard condition using the equation of state model, which is calculated by this separator train feature. Okay, the value is 788 kilogram per meter cube. It compares quite well with what we have in the report, which is 771. And the difference is only 2.25%. All right. And the same can be said of the calculated first stage GOR, which is for the model, it gives us 5,995.56 SAF per STB. It compares quite well with the value of written in the report, 5,919 SAF per STB. And the difference is only 1.8%, which is well below 10%. Okay, practically speaking, it is arguably acceptable match. Okay, this good agreement is a result of auto-match feature being used. And if the user were to repeat the above process again, let's say without auto-match feature, the difference will be much bigger. Okay, and I think at this stage we will also want to access the saturation pressure. Okay, but we will do that later on. So in this video, we define first the pseudo properties, we calculate the boiling point temperature, we enable the auto-match density, and then we check the separator train calculation, and we get, relatively speaking, good result, good match. Okay, in the next video, we will check the saturation pressure. Until then, see you and thank you.